Hello, welcome to this video. In this video, let us learn about reciprocating compressor and we will also derive work required for a single stage compressor without clearance volume. Now, what is a reciprocating compressor or what is a compressor? A compressor is a device which draws specific quantity of gas at lower pressure, compresses it and delivers it at a higher pressure, correct? So, there can be a compressor based on its action. We can classify it as a reciprocating compressor and rotary compressor. Now, reciprocating compressor is the action of the compression is reciprocating, whereas in rotary compressor will have a rotary action in order to compress the fluid. Now, the fluid can be any gas. Generally, we can talk about air. Okay, we have seen air compressors. There can also be compressors where refrigerant, for example, vapor compression refrigeration system we have seen, where refrigerant will be in the gaseous state when there is compression. Okay. Now, reciprocating compressor is a compressor where, as we have said, there will be a suction stroke, okay, during which the piston moves from left to right. Now, let us say this is the piston which is moving from left to right, which is causing the suction stroke. Okay. Now, during which there is a pressure drop. Because of the pressure drop, the suction valve will be open during this stroke, whereas exhaust will be or the outlet valve will be closed. Because of which the pressure drop here, the air comes in and this will execute the suction. And on the other hand, when piston is coming from right to left, this suction valve will be closed, only delivery valve will be opened. So, thereby we get the delivery here at relatively higher pressure, all right. Whereas, in rotary compressor, this is unlike reciprocating compressor, where in reciprocating compressor what we will have is intermittent like pulsating type of, because there is some part of the stroke you will not have the delivery, all right. During suction stroke we will not have the delivery. So, whereas in rotary compressor it is a continuous flow, where there are no walls here. As the rotary compressor moves, continuous flow will be there from inlet to the outlet. And we can also see that for a reciprocating compressor, the pressure ratio will be higher. We can have higher pressure ratio because of its operation, and mass is, since it is contained, it can handle low mass flow rate. Whereas in rotary compressor, it is suitable for moderate pressure ratio, whereas we can have high mass flow rate. In that case, we are going to use rotary compressors. Now, based on action, we can also classify them as single acting compressor and double acting compressors. Single acting compressor is where the compression takes place in only one side of the piston, whereas in double acting cylinder or double acting compressor, we can see that when, let us say, this side, left side, please concentrate, when this is executing the suction, this will be delivery here, because delivery valve will be open here. When piston is moving from right to left, that is delivery on the left side, this side we will have the suction stroke. So, that thereby we will have double acting. So, therefore, if we talk about the volume of gas delivered here, it will be, let us say, we will be knowing the diameter of the cylinder and length of the stroke. So, this will be pi d square by 4 into length, whereas on this side we will have the same stroke length, but remember we are doing this on both sides. So, this has to be multiplied by 2. Volume of air delivered in double acting compressor will be this much. So, we can also simplify this if you want to. So, pi d square by 2 into L will be the volume delivered in double acting compressors, all right. Now, let us take one more category, that is single stage compressor and multi-stage compressor. Let us say we want to compress to a ratio of 8 bar. Let us say the atmospheric pressure is 1 bar, and let us say we want to get the pressure which is delivery pressure at 8 bar. Now, this can be done in one stage, all right. So, we will have a bigger cylinder where we can bring down bring up the pressure from 1 bar to 8 bar. I mean, we are compressing it, all right. Now, this can be done in one single stage having uh, a single cylinder and a piston where air is compressed from initial pressure to delivery pressure in one stage. Whereas, multi stage compressor is like we go for two stage. Let us say I will go from 1 bar to 4 bar in one stage and 4 bar to 8 bar in the second stage. Now, this is possible, all right, and we can also have intercooling in between in order to bring down the temperature. Now, how does bringing down the temperature helps? We will discuss it in later. In multi-stage compression, using intercooling, that is cooling, will help the actually reduce the work required for compression. So, that is what we call it as intercooling. Anyhow, if there are more number of stages is used, then it is called as multi-stage compression. Now, let us derive work required in a single stage compressor without clearance volume. Now, let us take an example of a simple single stage reciprocating compressor without clearance volume. Without clearance volume is almost negligible. So, I am starting from here. Okay. So, and we will have the inlet valve here, we will have the inlet valve here and outlet valve here. Okay. This is our inlet valve and this is our outlet valve. Okay. Now, let us start from a point where we are talking about pressure volume diagram. At lower pressure, generally this pressure will be atmospheric pressure. Okay. Now, let us execute the suction stroke. Now, what is the suction stroke? Piston moves from left to right, top dead center to bottom dead center. That means we are going from here to the other side, right to left. Now, how does this happen? Inlet valve will be open, the piston moves from left to right. Now, because of the pressure drop here, since inlet valve is open, air is coming in. So, air will not let the pressure down. So, because of which we can assume that this has a constant pressure suction stroke. Okay. Now, this is assumed as constant pressure process. I will start from 4, I will, because we will generally start compression as 1. So, let us say we are executing 4 to 1 where piston is moved from left to right, that is executing suction stroke. Now, this is our 4 to 1. Now, what happens next is compression. Both the valves will be closed and pistons start moving from right to left. Okay. Now, let us take a point where both valves are closed and we will come to a point where we are talking about this green color, all right. Now, let us say this is our 1 to 2. Now, actually 1 to 2 is a compression process where both the valves are closed. Now, this is assumed to be polytropic process. PV power n is equal to constant. Now, this was our pressure is equal to constant and this is our suction pressure, all right. Now, after executing this suction stroke, we compressed it such that both valves are closed and we assume that it as a polytropic process. We can assume it like reversible adiabatic process, but we want the heat to be lost to the surrounding, otherwise it will become difficult for the compression process. So, we will assume that it is a polytropic process, all right. Then, now once we reach the delivery pressure, now P2 is the delivery pressure, we can open the outlet valve. At this point, the outlet valve will be open, then it is delivered. Now, let us assume that it is delivered at constant pressure. Now, again 2 to 3 is delivery pressure, it is at delivery pressure. 2 to 3 is at delivery pressure, and it is again a constant pressure process. Okay. Now 3 to 4 is just drawn to complete the cycle. 3 to 4 is just drawn to complete the cycle, but in reality actually the working fluid is gone out of the control volume. Now let us write what is one. Now this is volume constant. Yes. Now process 1 to 2 is polytropic compression. Process 2 to 3 is constant pressure delivery. Okay. 3 to 4 is actually constant volume, it is just drawn to complete the cycle, constant volume process, whereas 4 to 1 is constant pressure suction stroke. So, we have drawn our single stage compressor without clearance volume, and we are interested in work required. Okay, work required. Now, what will be work required? We have multiple processes. So, work net must be equal to W1 to 2, that is work required in 1 to 2. Similarly, W2 to 3 plus W3 to 4 plus W4 to 1. Okay. Now, remember W3 to 4 is going to be 0 because W3 to 4 is equal to 0 because volume is constant. For a volume constant, since we are talking about PDV work, if the volume is constant, work transfer will be 0. Now, let us write this equation again. W net is equal to, now what is W1 to 2? P1 V1 P initial V initial minus P final V final divided by N minus 1 plus, now this will be work 2 to 3 P2 into V final minus V initial, V3 minus V2. So, for the process 2 to 3 P initial is V2, P2, V final is V3 minus V2 plus this 0 plus work 4 to 1 is what? P4 into V1 minus V4. Remember, we are talking about pressure here, P4 is equal to P1, constant pressure. Similarly, here P2 is equal to, or P3 is equal to P2 because that is a constant pressure process. All right. Let us come back to this equation again. We will rewrite N minus 1 plus, I will multiply this to inside P2 V3 minus P2 V2 plus P4 V1 minus P4 V4. And remember, this is volume constant and we know that that is negligible clearance volume. So, therefore, V3 and V4 is equal to 0. Therefore, we can say that this term becomes 0 and this term becomes 0. Then what we will have is P1 V1 minus P2 V2 divided by N minus 1. And I will rearrange it. Since P4 is equal to P1, I will write it as P1 V1. Okay. I will write it as P1 V1 minus this P2 V2 I will write. Okay. Now, this can be further, we can take this common P1 V1 minus P2 V2. If we take this common, we will have 1 by N minus 1 plus 1, or we can rewrite it like 1 plus N minus 1 whole divided by N minus 1. Now, this cancels out, we will have work is equal to N by N minus 1, I am just rearranging N by N minus 1 into P1 V1 minus P2 V2. Okay. So, let us move forward. I want to represent this in terms of pressure ratio. Represent in terms of pressure ratio. I am interested in writing it in terms of pressure ratio because that is the important design parameter. I do not want it in terms of volume. So, how do we write that? So, we know that for 1 to 2 P V power n is equal to constant. So, I will try to do this now, that is work required will be n by n minus 1. I will take P1 V1 common, what we will have is 1 minus P2 V2 divided by P1 V1. Okay. So, process I will write this from process 1 to 2, we know that P1 V1 power n is equal to P2 V2 power n. Okay. Now, therefore, I am interested in replacing V2 by V1 here because I don't want volume here. I want to represent in terms of pressure ratio. So, V2 by V1 will be equal to P1 by P2. Now, this is their power n, or we can write V2 by V1 is equal to P1 by P2 whole power 1 by n, or this can be P1 power 1 by n divided by P2 power 1 by n. So, same thing I will bring back here, call this as equation 2, I will call this as equation 1. So, using 2 in equation 1, what we can do is W is equal to n by n minus 1, P1 V1 1 minus P2 by P1, and this will be P1 power 1 by n divided by P2 power 1 by n. Now, let us simplify it further. 1 minus P2 I will take it to the numerator, it will be minus 1 by n. So, P1 power minus 1 by n. Now, let us add the powers. So, we will have n by n minus 1 P1 V1 1 minus P2 power, we will have n minus 1 by n divided by, similarly here P1, if you write 1 minus 1 by n, that is correct. So, that will be something like this 1 minus 1 by n, that will be n minus 1 by n. So, that is what we are trying to do, n minus 1 by n, or we can rewrite like n by n minus 1 P1 V1 1 minus, now this P2 by P1 can be written as pressure ratio Rp power n minus 1 by n, where Rp is pressure ratio P2 by P1, that is delivery pressure by suction pressure, all right. Now, this is what is the equation we have got, W net, W in a compressor, work required in a compressor is given by this equation. Okay. Now, this equation will be negative. Why? Because it is a compressor is a power absorbing device. Above equation will give negative answer because all we have used is work transfer equations. So, because compressor is a work absorbing device, work absorbing device. However, if you want to keep that in positive because we do not want to handle negative sign every time, so we can rewrite such that we make it positive. So, n by n minus 1 P1 V1 Rp power n minus 1 by n minus 1. So, this is just to make the equation positive, we have rearranged the terms, all right. So, this can also be written in terms of, or this can also be written in terms of, if you do not know pressure volume, this is n by n minus 1, n by n minus 1 M R T1 we can write it like, instead of writing it in terms of pressure and volume, PV is equal to MRT I have used. So, Rp power n minus 1 by n minus 1. So, this equation also gives you the same answer. All right. So, these are the work transfer equations. These are the work transfer equations for a single stage compressor without clearance volume. Work required for a single stage compressor without clearance volume. In the next class, we will take work required in a single stage compressor with clearance volume. Thank you.